the draw has fallen upon me to be between you and your beer at the happy hour. But it's only prudent that I talk about a solution that we're working on to solve a potential and existential crisis, not only to oil and gas industry, but also to us as human species. And that's, in this case, produced water. Typically, I've been in this field. I have a PhD in chemical engineering. All of my career, from my master's degree all the way up to now, has been at the hybrid of energy and water nexus. How can we, make the best of both worlds? And looking at produced water, historically here in the US and many places in the world, produced water has always been a problem that somebody overlooked because there were easy options for disposing it, disposal wells and whatnot. We're running out of those options. So the second option becomes treatment. Produced water is complex. It's got a lot of pollutants in it. So it's very expensive and complicated to treat. How are we coping with these things? We're trying to reuse as much as we can. And that usually involves fit-to-purpose, customized solutions, either evaporative solutions, which are way too expensive to be tenable in most cases, and membranes. Nobody likes membranes because they're vulnerable. But let's see why nobody likes them. Because membranes, as they stand, are a passive separation process. You pass the water through the membrane. You have saturated salts that scale that membrane, and you have other stuff like biofilms, organic stuff, that foul that membrane. The membrane that is fouled and is scaled, and it has no control over it because it separates what it sees and it doesn't, what it doesn't, becomes highly inefficient very quickly. You have to put multiple pretreatment steps ahead of it, and you have to clean it so many times. It shortens its lifetimes, especially in produced water application, makes it a very expensive process, unsustainable. We know that very well. We're trying to solve that problem by radically changing that paradigm of separation from a passive separation into an electroactive separation. When membrane is electrically conducting, and when you apply a low potential AC to that membrane, you basically turn that feed channel into an electrochemical cell, keep all of those charged particles away from the surface, and help them make the membrane inherently anti-scaling and anti-fouling, make the pollutants go away or minimizing the scaling and fouling potential without having to rely to too many pretreatment steps. Make desalination processes leaner, more scalable, and easy to operate. Feels like an old RO system, but now with a superpower, with a membrane in the driving seat, not necessarily other way around. Our goal is to significantly reduce the capital and operating cost of desalination for challenging applications such as produced water. The way we do it is that we put an electrically conducting flat sheet on the surface of a membrane. It will look like something like this, much bigger though. And we roll them into a standard spiral wound module, used everywhere in the industry. This is the smallest one because, frankly, this is the only one that I could fit in my suitcase, but they're bigger ones. And when you do that, you can independently energize those modules. 2 watts, less than an LED light for each one of them, and then put them in the standard RO pressure vessels. It looks the same, but it's in a smart membrane system now, much leaner. So we started with produced water. This is not an accident. We've been thinking about this problem pretty much all of our career. In Wyoming, at an existing plant, they were trying a different treatment because the existing treatment was very expensive. We demonstrated that we can eliminate softening process, often a very expensive process. 35% OPEX savings, 30% footprint savings demonstrated. More recently, my team and myself, back in 2018, this is California, Ventura County, at an oil field, we tested a desalination process, several stages of pretreatment. It was a nightmare to operate. It was technically successful, but it was expensive, so it wasn't commercially successful. That was one of the chip on my shoulders as an entrepreneur. Back in 2025, we significantly reduced that footprint by eliminating the softening clarifiers. Not only the footprint, but also the chemical usage, waste streams, and so on and so forth. 60% less footprint and 56% less cycles. More importantly, 13% carbon emissions reduction over the lifetime of these processes. 3 years old, this venture, we have garnered significant industrial traction. The industry gets it, many respectable awards. We initially started by grants and safe notes, and then we raised a seed round. We're currently raising a second seed round because we have demands. Those logos that you see at that stage, they hold 20% of the world desalination installs. We are piloting with them. So we have to meet that demand, so we have to expand our production capability, and that's why we're raising. Our production is TRL7 according to Department of Energy. And what we like to do, what we are here for, is to work with Devin or all of you, if you're interested, in some of your existing assets that you have a disposal problem. We have systems that are ready to deploy. They are out there. We can deploy them tomorrow. We have assets available. And we like to work together to define what is the success goal for you in terms of commercial cost. We understand those commercial constraints. How would you like to approach this? But also, we'd like to commercially scale up. We want an install, essentially, a commercial install, and we're hoping to work together. For us, it's good to go any day. And the outcomes is we like to help solve a problem that we're passionate about, but also, I'm not Gandhi, I'm maybe a capitalist version of it, but we like to be able to solve a problem commercially available to everybody. Now, Tulsa is a fantastic place for us. Why? Because most of the desalination market and produced market, a lot of it is in the Gulf Coast states. Desalination is becoming more and more. You may not notice, brackish water desalination is becoming the largest market as far as desalination is concerned in the world, much bigger than what the Gulf states in Middle East are doing, or Israel is doing, or whatever. That is because we are running out of fresh water. And we like to create good jobs, jobs of the future, advanced water treatment, specialized jobs of the future, skilled jobs of the future. That's what we're passionate about. The team is great. Everybody talked about how great they are, and we are, nonetheless, we've dedicated decades, over 2 decades of our career into this. We've started many startups that delivered many commercial solutions in produced water sector. Most of them are out there right now in commercial settings. And if you don't believe that, we wrote a book as well. Please go ahead and read it. Why partner with us? In summary, we have a proven differentiated technology. We have deep domain expertise. This is what me and my colleague have dedicated our commercial and professional life to solving. It's an scalable, financially viable options demonstrated. And what we're looking for and what we're lacking is commercial partners, people that can give us a shot at commercial installations. Thank you so much for your time.